So this video we're going to extend our knowledge of quadratics, trig quadratics a little bit. The process we used in the last video where we reversed operations, we did that because there was only one trig argument. That's going to be a little bit different today. Today we're going to be looking at equations that look something like this. 2 sine squared of x minus sine of x minus 1 equals 0. Now, what I'm really going to think about, first of all, I'm going to key on to this idea that there's a sine squared and also a sine. So there's no way that I can reverse this. It just won't work. What I'm going to think about is how would this work if I factored this? 2x squared minus x minus 1 equals 0. If I've got multiple trig arguments and I'm dealing with a quadratic, factoring is the only approach I can realistically take. Good news is we're not going to use the quadratic formula or completing the square, any of that stuff. We're going to go with the process of factoring. So if I had 2x squared minus x minus 1, which is equivalent to this, it's not the same thing, but I would factor it like this, 2x and x, and then a minus 1 here and a plus 1 there, and that'll work out. So check out what happens when I actually extend it to this. I'm going to take this factoring that I've got, and it's going to become this, 2 sine of x plus 1 sine of x minus 1. Let's sink that in for just a second here. So we're taking that sine of x and ignoring it a little bit and thinking of it just as x squared. The same thing with the sine of x, we're ignoring it. And technically we should use a different variable, but we've been using x so much that we're going to continue with that. But then once we've got our factors set up ready to go, I can take my factors and set them equal to 0 using the zero product property. So once I solve those, I'm going to bring over my 1 and divide by 2, giving me the sine of x equals negative 1 over 2, and the sine of x equals 1. I'm looking for the solutions to those two equations. So I'm getting kind of a 2-for-1, two trig equations at one time. I'm looking for sine of x equals negative 1/2. That's going to occur in quadrant 3 and 4, and it's going to occur at the pi over 6's. So 7 pi over 6 and 11 pi over 6. Sine of x equals 1 is going to occur at pi over 2 and just pi over 2. So those are my 3 solutions to that trig equation. Now, sometimes it's not set up perfectly for us, and that's where we're going to have to do a little bit of work. So on this next one, we've got tangent squared of x equals tangent of x. Again, I want to use that zero product property, that factoring concept, because I've got 2 trig arguments, one squared, one not, so I cannot use reversing operations. So using the zero product property, what I'm going to have to do is bring that tangent of x over to the other side. Subtract it. Tangent squared of x minus tangent of x equals 0. Now, this is really the same thing as x squared minus x equals 0, which might not be very obvious in what we're supposed to do, but we have a common factor that we could take out. We can take an x out of both of those things. We're going to do the same thing here. I'm going to take a tangent out of both. I'm running out of space here. I don't want to move my unit circle. But I'm going to set my 2 equations then. So tangent of x equals 0. And my other equation, tangent of x minus 1, equals 0, which means the tangent equals 1. So I'm looking, where does the tangent equal 0? That's where the sine is 0 and the cosine is something else. That's going to occur at 0 and at pi. So I've got 2 answers there. I want to know where's the tangent equal to positive 1. That occurs at quadrant 1 and quadrant 3 at pi over 4 and 5 pi over 4. So I've got 2 solutions. Now again, I'm bringing stuff over, factoring out a greatest common factor if I can, and then going through the process of setting those factors equal to 0. So let's extend this a little bit. Let's do a little bit more with this. Let me see if I can grab these equations and get rid of them so we have a little bit more space to work with. All right, that works. Okay, now, how about one like this? Cotangent of x, cosine squared of x, oh boy, here we go, equals 2 cotangent of x. So again, our process is going to be very similar to the one we just did with the tangent. We're going to try and bring everything over to one side so I can go through the process of factoring. So I'm going to subtract 2 cotangent of x from the other side. Then I can factor out a cotangent of x. Now, take each of your factors, set them equal to 0. Cotangent of x equals 0. Cosine squared of x minus 2 equals 0. So, our next step is to solve these. That one's already done. Good, ready to go. This one I'm going to have to do a little bit of work. Cosine squared of x equals 2, which means the cosine of x equals plus or minus square root of 2. Now what that means, is that this particular equation will not have a solution, but I still have to look at this other one because it's still possible that I have valid answers. So I'm looking for where the cotangent is equal to 0. So that's going to be where the cosine is equal to 0, but the sine is equal to something else. That's going to occur at my pi over 2's. So pi over 2 and 3 pi over 2. Those are my two solutions to that equation. So that's kind of the idea we're looking at. We're looking to if it's a quadratic and everything's on the same side and we've got like quadratic expressions, we can go through the process of factoring, our typical traditional factoring. If we've got multiple trig arguments of different types, cotangents and cosines, tangents and sines, or whatever they are, or we don't have that linear term, that -1, the +4, whatever it happens to be, then we're going to use that greatest common factor process. But the idea is still the same. We're going to take our factors, we're going to set them equal to 0, and we're going to find out the solutions to our equations. Now again, sometimes different pieces don't always have a solution, but the other piece might, so we have to consider that.